Resonance structures. So earlier we drew Lewis structure of carbonate ion, and we drew as like this. Okay, so this was the Lewis structure of carbonate. However, we talked about how this double bond can be between the carbon and oxygen on the left side. So also this is the correct Lewis structure of carbonate as well. And lastly, we can have this scenario where carbon and oxygen on the right has a double bond and the other ones are single bond. So all these three are correct structure for Lewis structures. So really, why do we have these three structures? In fact, if you measure a bond length between carbon and oxygen for all these three, they have all same bond length. And usually double bonds are shorter than single bonds. So you're like, well, if they have the bond length between this carbon and this oxygen, this carbon and this oxygen, and this carbon and this oxygen, if they're all equal, then that doesn't make sense, because usually single bonds are longer and double bonds are shorter. So what's really happening? What's happening here is actually the actual Lewis structure of carbonate is average of these three. Okay, so really when you're drawing it, it's hard to draw average of these three structures overlap together. So what do we call these? Okay, we call them resonance structures. And for carbonate ion, you can see we have three resonance structures. Okay, and usually resonance structures occur when you have a multiple bonds, usually double and triple bond. If you have Lewis structure that only has single bonds, they do not have resonance structures. Okay, so again, resonance structure just means there's more way to draw Lewis structure, and what it means is that these double bonds or multiple bonds, okay, you draw like this, but in fact it's the average, the actual Lewis structure of carbonate is the average of these three resonance structures.